Hi there, 5 Crew families, and welcome to Lunch with Miss Krupat. Today we're going to be learning a couple new concepts and reviewing a couple old concepts. And this will be helpful so if your student is having trouble with homework or is struggling to study for the test at the end of the week, now you'll know exactly what they're learning in class and maybe how to help them. So the first thing that we're going to review are exponents. So we've done this in the past, but we're going to go into it a little bit in more detail this week, and then we're going to move on to expanded notation. So we also already went over expanded notation, but now we're going to bridge our knowledge of exponents and learn a new form of expanded notation. So the first skill that we're going to learn today is exponents through the game Double Trouble. So students are going to learn this skill and this game during class, but they might want to do it for homework. They could also use this to study for our test. It would be a great way to study. And the way you play the game is that you have 2 dice, and these dice represent the base and the exponent. But it's the challenge of the student to figure out which number is going to be the base and which will be the exponent. The point is to try and get the largest product. So mentally, students have to figure out, is it going to be more beneficial to have a bigger base or a bigger exponent, and when the situation might require the reverse. So if a student rolls a 3 and a 5, they might think, which number is going to be bigger? 3 to the 5th or 5 to the 3rd? So maybe the student chooses 3 to the 5th as what they think will be the bigger number. So here they would write 3 to the 5th. And then where it says stretched out multiplication, they would write the equation. So it would be 3 times 3 times 3 times 3 times 3. So that's 3 5 times. Many students might be able to do this using a pen and paper or using mental facts, maybe if it's a little bit smaller. But since we're going to be playing this game a lot and using a lot of big numbers, if students can't automatically say what the fact is or use maybe 1 or 2 equations to figure it out, they can use a calculator to help them. So in this case, the answer is 243. So then after that, the student might roll the dice again to fill out their second row. So say they got, a 2 and a 3. That's what they rolled. And maybe they want to try out 3 to the 2nd. So they're going to put 3 to the 2nd here. For the stretched out multiplication, they would do 3 2 times. So 3 times 3, which is 9. And then they would continue to do that for the rest of the rows. And then at the end of the game, they would add up all of their products and get the total number of points. So now if your student has mastered double trouble, they can add in another dice and spin 3 dice. So if your student spins 3 dice and they get a 3, a 4, and a 5, and they think, which 2 numbers could I add up to get a base, and then which number am I going to use as my exponent? So say the student thinks, I'm going to use these 2 numbers as my base and this number as my exponent. So to get their base, they would add these 2 numbers together. So they would get 7 as the base, since that's 3 plus 4, and they would use a 5 as their exponent. So then for the stretched out multiplication, they would do 7 times 7 times 7 times 7 times 7. And again, they could do this on their calculator and eventually get 16,807. So let's say they keep going with all of these columns and eventually end up with these products. Maybe they got a 10, a 7, 100, and 1,000. So they might have used 2 dice for some of them, 3 dice for some of them, but in the end they would add up their whole product and would get final total points of 17,924. During September in math, we worked on writing and saying big numbers, and students are going to be using that skill to then learn how to do different types of expanded notation. So if we start with the number, say 321, and we want to create this first form of expanded notation. Students have already learned this, and the way they learned it was that 321 is like a slinky. We know there's lots more numbers in there, and it represents a lot of different numbers in terms of place value. So if we just expand that slinky and make the number bigger, we expand it, we can see all of the different numbers that 321 is composed of. So we're going to start with 3. 3 is actually in the hundreds place, so it would represent 300. Then we're going to add another number. So the next number is this 2. It's not just a 2, it's in the tens place. So it's 2 tens, which is really 20. So we're going to add a 20. And then our last place value is this 1. It's in the ones place, and there's just one of them, so we're just going to add the 1. So if students want to check their work, they would see 300 plus 20 plus 1 does in fact equal 321. So now we're going to expand our knowledge of expanded notation one more level and do expanded notation with multiplication and addition. So how can we further expand this number? We're going to start with parentheses and try and build the number 300. So how can we break 300 further down into its components? So we might say we could do 3 times 100. That would definitely equal 300. And then we're going to add our 20. So our 20 is actually 2 tens, so 2 times 10. And then our last number is 1. And since it's in the 1 place, we're going to show we know that by saying 1 times 1, which the students just know equals 1. So now that we've been learning to write exponents, we're going to use that knowledge to learn one more form of expanded notation using multiplication, addition, and exponents, which is really exciting for the students. So we're going to start off just like we did in the previous form with our parentheses, and we're going to say 3 times what number is going to equal 300. So we're going to use this 100 but build it with exponents. So students know that 100 in exponent form is 10 to the second power, 10 to the power of 2, or 10 squared. If they forget, they can try and build the number, or they can remember that 100 has 2 zeros. That's where we get our 2 exponent from. Then we're going to add our 2 times 10, so our 20. We're going to say 2 times 10 to the first, because we know that 10 to the first is just 110, which we have here. And then our last section is just the 1. So we're going to do 1 times 10 to the 0, because we know that 10 to the 0 really equals 1. Thanks so much for watching, and stay tuned for our next video coming soon.